So we've seen a way to do an esterification, right? So you got to remember, when you use these words, what's an ester? That's an ester. So we've seen a way to do an esterification in basic conditions from a carboxylic acid, right? With strong base, and we do an SN2. But we can also do an esterification with acid, and that's acid catalyzed. Now this is a special one, but I wanted to show it to you. 1, 2, 3, 4, 5, 6. It's going to make, in this case, a 5-membered ring. Remember these things. 1, 6, 2, 3, 4, 5, plus, and there's 1. So there's a cyclic ester. It's called a lactone, but it's just an ester. And we did this with acidic conditions. So we've done the basic, now we're going to do it with acidic conditions. Right? So let's see if we could do that. So the first step is going to be what? Even though this is a carboxylic acid and we have strong acid around, we're going to do a protonation. So this is called an esterification. Right? So we're going to protonate. Right? We always do the same steps. In acidic conditions, the first step will be, no matter what, will be a protonation. Use the acid. Right? Use the acid. You need to use it. Okay? That made that a better electrophile, this carbon in there. What's going to happen next? Our nucleophile in this case is in the same molecule, right? So I made this point, I think, about intra versus inter. Somebody had a good question. What's this underneath the arrow? Things underneath the arrow are usually the solvents. So usually those things are in high abundance. So why in this case did I not use this? Why did I use this alcohol instead of this alcohol? It's just a matter of proximity, right? It's easier to give yourself a high five than get a high five from somebody else, right? It's just faster, right? And so that's just the way this is going to happen. Somebody also had a good question about, well, is there a limit to ring size? There is. So carbon, like 5 and 6 are kind of the sweet spot. So a 5-member ring or a 6-member ring. You can make 7-member rings, but anything smaller, anything bigger becomes a lot more difficult because it's either less likely, right? Then you can think about the two hands are way, like me. I have these long arms. These hands are trying to find each other to react, right? Or they're too tight and they just don't have the angles, right? My one hand, they're too close together. So ring size 5 or 6 and sometimes 7. So that's why it happens in an intramolecular sense. So you get that addition. We make a tetrahedral intermediate. Need to balance our charges. Make sure we're not losing anything. Let's number those carbons again and oxygens. 2, 3, 4, 5, 6, 6, 5, 4, 3, 2, 1. Right? Balance my charge. I need to have an overall plus charge there. So at this point, you do some proton transfers, and then you kick out, right, this, and get the water, right? So that's the esterification, right? Esterification in acid, in acidic conditions. So I make esters in acidic conditions.